Physical quantity. Okay, this is the syllabus. All physical quantity consist of the numerical magnitude and unit. For example, the speed. For example, we are on a car moving with the speed of 60 kilometers per hour or 10 meters per second. Okay, so this is a numerical value and this is a unit. Okay, so the second requirement of the syllabus: make reasonable estimate of physical quantities included within the syllabus. Estimate, like I asked you to estimate the distance from your home to the school, Recall the following SI-based quantities and their unit. Try to remember 5 among the 7 base unit, 5 over 7, because remembering all 7 base units are not very easy, But 5 among them are mass, length, time, current, and temperature. Express the derived unit as the product or quotient of SI-based unit and use the derived units for quantities listed in the syllabus and appropriate. Can you give me an example of a derived unit? Example, anything, pressure, volume, acceleration, force, etc. Just name one.
Force.
Force, okay. Force. So what's the unit of force?
Newton.
Newton, big N. And can you write it in form of the products or ratio of the SI, the base units? Newton equivalent to what? Remember this one? F equal ma. Newton is unit of force. What is the unit of mass? Kilogram. And what's the unit of acceleration? Meter per second square. Second square. Okay. So this thing, the whole thing here, kilogram times meter per second square, is the base unit form of the unit of force. And because it's long, so we use only one single name, a derived unit, to represent it. Okay, Newton. Later, when we do some example, you see that sometimes if we want to write another unit, represent it in form of the base unit, we'll have a very long representation. Okay, let's see that. For example, the speed shuttle constant gamma has no unit. Okay, how about the multiple choice question here? Here, for example, here. This is the equation for energy of a molecule. K is a constant called Boltzmann constant. K here is called Boltzmann's constant. There's 2n, okay? Constant. Where T, the absolute Kelvin temperature, what is the SI base unit of K? K. So what is the unit of energy? Let me write that again. Energy is 3 over 2 kT. The unit of energy is joule. And we need, and joule here is a derived unit, not a base unit. So what formula can we use to represent, to convert joule to the base unit? The definition of energy is actually equivalent to work, and work is determined by F times D, force times distance. Yeah, force times distance, remember? Force times distance. And force is m, which is the mass, times acceleration, and then times the distance. Okay, times the distance. So energy is actually kilogram for the mass. Acceleration is meter per second squared. Okay, per second squared. And then times the distance here. The unit of distance is meter. Okay, so we have meter, 2 meter here and meter here, and we can combine them by using the square. Okay, so this is the unit of energy. Okay, 3 over 2. We can ignore the constant because we are analyzing the dimension, meaning the unit, dimension of the quantities on both sides of the equation. Okay, here is the unit of K, the dimension of K, that we need to find it. Okay, and temperature, the unit of temperature is Kelvin, which is a base unit. We don't need to convert it. Okay, so what is the unit of K? The dimension, the unit of K is, take the quantity here on the left and divide the Kelvin, right? Like A equal B times C. So B is A over C.
Yeah.
Okay, so the unit of K is kilogram meter square second minus 2 divided by Kelvin. And instead of writing Kelvin at the bottom, I can write here power minus 1. Okay, V is the speed, speed. So the unit of V is meter per second. Okay,
Yeah.
equal to, we're gonna write the square root as the power 1/2. Okay, this is the unit of gamma. We need to use this square bracket to indicate the unit or the dimension of gamma. Then the pressure is Newton over meter square, and then later we will convert the Newton to the base unit.
Yeah.
Draw the density. Density is kilogram per meter cube. Okay, Newton per meter square for the pressure is equal to, Newton here is kilogram, force, ma, force equal ma, kilogram times meter per second square, and then times meter minus 2. So simplifying, multiplying m and m minus 2, we get kilogram meter minus 1 and second minus 2. Okay.
Yeah.
And then put in here the unit of gamma, kilogram meter minus 1 second minus 2, all of that power 1/2, and the bottom also power 1/2 at the bottom, kilogram meter minus 2. Okay, now do it one more step, meter, one more step.
Oh, can we just simplify like the top and bottom?
Yeah, exactly. Yes, we can do that. Removing, simplifying kilogram, meter minus 1, meter minus 2. Let's simplify that thing.
And
so that meter minus 2 at the bottom. And then the top, the unit of gamma, second minus 2 still remain, minus 2. And all of this thing power 1/2 equal meter per second. One more step. Power minus 1 here, multiply with power 1/2 multiply with minus 2, become s minus 1. Okay, meter minus 2 at the bottom will become, when we divide it, it become meter square at the top. Okay, and then power 1/2, it become just meter. Okay, just meter. And then the unit of gamma, and finally meter per second here. So we see that they are the same thing.
Yeah.
You can simplify them, so gamma has no unit. So sometimes you will see a difficult question like this. In paper 2, the multiple choice paper, they will give you 4 options. They will ask you, what is the unit of gamma, for example? And there's an option like no unit. Or they list the 4 very complicated units, like in the previous example up here.